Good day, everybody. How are you all doing? Today, we are going to talk about hypothesis test for the mean. So, here I go. Good afternoon again. Today, we are going to talk about hypothesis test for the population mean. As you know, hypothesis means educated guess. We never really know the population mean, but we are going to make an educated guess about a population mean characteristic based on sample data. Then we are going to establish procedure to test whether our educated guess is in the correct ballpark or not. So here they're showing you the two different kinds of alternate hypothesis that we can have. One will be a right tail test. Notice the first one, upper tail test or right tail test. The alternate hypothesis is mu greater than. How do you know it's a right tail? Look at the symbol indicating greater than. The two slanted lines meet at an edge pointing to the right. That means the test statistic value will be in the right tail of the standard normal distribution. In this case, mu is greater than hypothesized value is the value in the null hypothesis. That is our educated guess. So what will be the p-value or the probability value of obtaining a test statistic at least as extreme as what we have calculated from our sample, is the value on the right of the test statistic under the standard normal curve. If we do not know the population standard deviation, then we will use a T curve or student T distribution with n minus 1 degrees of freedom. DF stands for degrees of freedom. N is the sample size. P value is still the value to the right of the test statistic under the T curve with n minus 1 degrees of freedom. For a lower tail test or a left tail test, the alternate hypothesis mu population mean less than a hypothesized value, the two slanted lines indicating less than meet at an edge pointing to the left, which means the test statistic will fall in the left tail or the lower tail of the T distribution, and p-value will be the probability value of obtaining a test statistic at least as extreme as what we have obtained. That is, the p-value is the area to the left of the test statistic under the standardized student distribution with n minus 1 degrees of freedom, where n is the sample size. And if we have an alternate hypothesis of mu not equal to a hypothesized value in the null hypothesis, then depending on whether the test statistic will fall in the right tail or in the left tail, for the right tail, the p-value, probability value will be twice the area to the right of the test statistic. And if the test statistic falls in the left tail, the p-value will again be twice the area to the left of the test statistic under the T distribution with n minus 1 degrees of freedom. Okay. So again, our null hypothesis is the mean equal to a hypothesized value. This is the value for the null hypothesis, and we calculate a test statistic T, okay, where we will compare the sample mean to the hypothesized value in the null hypothesis. That is the deviation of the sample mean from the sample data to the from the hypothesized value in the of the population mean in the null hypothesis. The deviation, which is the difference, the deviation is divided by standard deviation of the sampling distribution or standard deviation of the probability distribution of X bar, which is given by standard deviation of the sample S divided by square root of the sample size. Okay. So again, there are three kinds of alternative hypothesis. One is a right-tailed, in which case the alternate H sub A colon mu greater than a hypothesized value. The other is a left-tailed, in which H sub A mu less than a hypothesized value. We already discussed if we have a right-tailed test, then that we calculate the test statistic, and the p-value is the area to the right of the test statistic under the t-curve with n-1 degrees of freedom, sample size -1. And for a left tail test, p-value is the area to the left of the test statistic under the t-curve with n-1 degrees of freedom. And if we are doing a not equal to, which is a two-tailed test, then depending on whether the test statistic t is in the left tail or on the right tail, if it is in the left tail, then the p-value is twice the area to the left of the test statistic. And if the test statistic falls in the right tail, then the p-value is twice the area to the right of the test statistic under the t-curve with n-1 degrees of freedom. Assumption x bar means the sample mean, and sample standard deviation are the sample mean and the standard deviation from a random sample. That's important, simple random sample. And the sample size is large, generally n greater or equal to 30, or the population distribution from which the sample came is at least approximately normal. The articles Americans spend nearly 2 hours a day shopping online at work, studies suggest, customizes data from a survey conducted by Finder.com. The title of this article suggests that 2 hours a day spent shopping online at work might be plausible for the mean time for the population of all American workers. That is the population mean for all American workers. The actual survey data can be found in the blog post. In a representative sample of 2020 adult Americans, the mean time spent online shopping while at work was 1.7 hours. The sample standard deviation estimated from a relative frequency distribution that appeared in the blog post was 0.8 hours. Do the survey data provide convincing evidence that the population mean time is different from the value of 2 hours suggested by the article headline? Hypothesis can be carried out to answer this question. So, is different from, that is the alternate. So, the null hypothesis, mu is the population mean time spent online while at work. Null hypothesis is mu equal to 2. Alternate, mu not equal to 2. So this is a two-tailed test. Our level of significance alpha is 0.05. We have to calculate the test statistic t, which is to compare the sample mean with the hypothesized value in the null hypothesis, that deviation divided by the standard deviation of the sampling distribution. Okay. This test requires a random sample and either a large sample size or a normal population distribution. Sample was selected to be representative of the population, so it is reasonable to regard this sample as if it were a random sample. Relative frequency distribution was still given in the blog post. With a partner, discuss the following. Be prepared to share your insights in the class. Based on the given relative frequency distribution, why would it not be reasonable to assume that the population distribution is approximately normal? Look at, it is skewed to the right, this distribution, because between 0 and 30 minutes, it is 0.46. 46% of people spend between 0 and 30 minutes shopping at work. The remaining are small relative frequency, but there is large numbers too. So the distribution is skewed to the right, so it's positively skewed. Answer: because the given relative frequency distribution clearly shows the distribution of mean time is not symmetric and is positively skewed, that means an extended tail on the right, it is not reasonable to think that the population is approximately normal. However, the sample size was large, n equal to 2020, so it is reasonable to proceed with one sample t test. So in the numerator of the test statistic, we want to calculate the test statistic. We'll compare the sample mean of 1.7 with the hypothesized value in the population standard deviation, which is 2. Hypothesized value in the population, which is 2. So sample mean is 1.7, hypothesized value of the population mean is 2. Compare 1.7 to 2, or the deviation of 1.7 from the population mean of 2. That is in the numerator of t and divided by standard deviation of the sampling distribution of x bar, which is the sample standard deviation divided by square root of the sample size. So in order to calculate the test statistic, okay, so what will we do? We will put the left parenthesis first. So the sample mean is 1.7. From that, you subtract hypothesized value of the population mean of 2. That difference is divided by, and then again, then you put the S value, which is zero point 0.8 divided by, the horizontal line is divided by second x square. Why second x square? Because you want to divide sample standard deviation by the square root of the sample size, and then hit enter. So type under the square root 2020 and hit enter. Let's calculate this again. So left parenthesis 1.7 minus 2, right parenthesis divided by, put a left parenthesis in the denominator, divided by left parenthesis 0.8 divided by second x square square root 2020, right parenthesis, and hit enter. And the p-value is minus 6.85. So the test statistic uh, falls on the left tail. Okay. Now we need to calculate the p-value, which will be twice the area on the left of minus 16.85 under the T curve with 2020 minus 1, 2019 degrees of freedom. If I have TI-84, I can do that easily. So I will do second verse and I go to TCDF, which is number 6. So second verse and then number 6, TCDF. Remember, I start my calculation from a very large number on the left-hand side, which is minus 1 E99. That is a negative 1 followed by 99 zeros, very large number on the left, which is already set in the calculator. The upper is where I want to stop, is minus, next to enter, 16.85. My degrees of freedom is sample size minus 1. So 2020 minus 1 is 2019. I go to paste, hit enter, and again enter. And that p-value is 0. But because it's a two-tailed test, we multiply 0 by 2, it's still 0. So p-value is very small. If you assume, let's see, they have given us a level of significance of alpha equal to 0.05. So p is less than alpha, decision, reject H0, conclusion at alpha equal to 0.05. There is enough evidence to suggest that there is enough support for the alternate hypothesis, mu not equal to 2. Okay. Because the p-value is less than alpha, the null hypothesis is rejected. There is only convincing evidence that the mean time spent for shopping at work is not 2 hours. Because 2 hours is not a plausible value for the population mean, the article Americans nearly spend 2 hours per shopping at online may be misleading. Rejecting H0 due to test statistic implies statistical significance at the chosen alpha level. Statistical significance indicates the observed standard deviation from the expected values under the H0 is unlikely due to chance alone. However, statistical significance doesn't necessarily imply a practical difference from the null hypothesis in real world terms. Rejected H0 may suggest to practical discussion between the actual population characteristic and the null hypothesis stated value. Okay. Let mu denote the average score on a standardized test for all children in a large school district. The average score for children in the United States on that standardized test is 100. District administrators are interested in testing null hypothesis of mu equal to 100 versus alternate mu greater than 100 using a significance level of 0.001. So they collected a sample of 2,500 children and resulted in N Values n equal to 2500, sample mean is 1101.0, sample standard deviation is 15.0. So it's a right tail test. Let me show you how to do this test by the calculator. So you do stat, highlight test means move the cursor on the top row to test, then scroll down to t-test. T-test, why? Because we do not know the population standard deviation. Hit enter. Input should be flashing on stats because we know the summary stats of the sample. Our null hypothesis in the our value of the population mean in the null hypothesis states that mu equal to 100. That is our mu zero value. That is the value in the null hypothesis is 100. The sample mean x bar is 101.0. The sample standard deviation Sx is 15. The sample size n is 2500. And what is your alternate hypothesis? That's in the fifth line. We have greater than mu zero or greater than 100. So bring the cursor on greater than mu zero and hit enter so that it's flashing on greater than mu zero. Then go down to calculate and calculate. The test statistic is 3.333 and the p-value is it is 4.35, cannot be 4.35. Probability cannot be greater than 1. So we should look at the E minus 4 at the end. That means actual p-value or probability value of obtaining a test statistic at least as extreme as 3.333 is 0.0004. E minus 4 indicates the first number 4 is at the fourth place after the decimal. The first three places after the decimal are filled with 0. So it's 0.0004. Let's see if they have given us any value of alpha, level of significance. Yes, it's 0.001. Okay. And our p-value is 0.0004. So p is less than alpha. Decision reject 80. We conclude at alpha equal to 0.001. There is enough evidence to support the alternate that mu greater than 100. Okay. P-value is less than 0.001. So we can convincing evidence. We all went over that. What they're saying in the second paragraph, however, with sample size 2500 and a sample standard deviation of 15, the point estimate x bar of 101 is very likely close to the actual value of mu. This means that it looks as though 80 was rejected because mu equal to 101 rather than 100. From a practical point of view, a 1-point difference may not be important. A statistically significant result does not necessarily mean that there are any practical consequences. Okay, so we will stop here today. If you have any question, comment, please do not forget to write me a note and I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And also, please do not forget to click on the bell button because that will notify you every time I upload a new video. Again, thanks for watching and please subscribe to my channel by hitting the red subscribe button. Again, take care. Have a nice day. See you later. And please do not forget to watch me tomorrow when I'll be uploading a new video. Take care. Have a nice day.